Hello, welcome to the first of the Organic Chem Really Labs. Today we're going to perform our melting point lab. The melting point, if you'll remember from General Chemistry 2, is defined the temperature where the solid and liquid forms coexist. Okay? And that's because it's the temperature where you've given just enough energy for the particles to slide past one another, and so to become liquid, okay, in some of them, or some of them that have been sliding past are sticking together. Each substance has a particular melting point, which can be experimentally determined, okay, and most of them have been. Okay. Mixtures, on the other hand, as opposed to pure substances, okay, if you'll remember your colligative properties of solutions, when you add a solute to the solution, its number of things differ, okay, and that is one of those things is that the freezing point depresses. Well, as it turns out, the freezing point and the melting point are the same temperature, just approached from different sides. So if we have a mixture of solids, okay, then its melting point should be lower than that of either of the pure solids that have been looked at. In addition to lowering the melting point, having an impurity there or something else there actually broadens it into what's known as a melting range. So we can use these two facts, that is, does our substance match an experimentally determined melting point, or is it the same, is it a melting point or a melting range, to do a number of things. So we can help determine the identity of an unknown by taking its melting point and looking and saying, well, that's completely different than the melting point that's been published for what I thought it was, so I know that's not that. Or, oh, I think it's this substance A, and I take its melting point and that matches, and I've got a pretty good indication then that I'm on the right track. Okay. By the way, this is usually confirmed by doing what's known as a mixed melting point, where you take equal amounts by mass of the unknown that you were working with and the standard A, in that case, that we thought it was, mix them together and take a new melting point. If the substance really is, your unknown really is substance A, then nothing's going to happen to the melting point and it should come back exactly like what you've already been working with. If, however, your substance is something different with the same melting point, it doesn't really make a lot of intuitive sense, but unknown, substance A, same melting point, mix them together and you're likely to get a melting range. And so that way the mixed melting point can confirm your identity based on melting point data. You can also use melting points to determine the composition of a mixture, which is what you're going to be performing today. Okay, so today one person is going to be determining the melting point for diphenylphthalate. One person is going to be determining the melting point of salicylic acid, and a number of you are going to be determining the melting points for mixtures of those two things together. From that data, you're going to create a standard curve and then use that to extrapolate the percentage of DPP in your unknown. So some procedural notes. Okay. Here again, just going through what's in the PDF, okay, and highlighting some things. Number one, each of you is going to be doing individual work and then sharing information with the class for this lab as a whole. You'll be given an assigned substance, either DPP, salicylic acid, or something like a 1-to-1 mixture or a 1-to-2 mixture to perform as I need to learn this technique. Then you're also going to be assigned an unknown. That unknown is a mixture of DPP and salicylic acid. What you don't know is the percentage of each of those components in the mixture. So each of your students should perform your melting point determination for your standard or your assigned mixture, and then your unknown as well. Okay? Share the information on the melting points of the DPP or the salicylic acid or the mixture that you were assigned with the class. Do not share your unknown melting point information. That's yours and yours alone. Outside of class, you're going to graph the data in your notebook. Okay, now that's going to consist of an average point temperature where the standard or known mixture started to melt, an average of where it finished melting, and so you should have two lines on the graph. One that includes where the low point, where each of the data points started to melt, and one that indicates where it finished melting. Then you're going to, on the y-axis, mark where your unknown started and finished, read across, and extrapolate. Correct identification of the percentage of unknown in your unknown, okay, of DPP, clearly written in your notebook where I can find it while I'm grading notebooks, okay, is worth 12 points of product grade. Okay? The closer you get to the actual percentage of DPP in your unknown, the more of those 12 points you earn. Okay? Not having it where I can find it in your notebook results in 0 points. So you really want to make sure and get it written down. Okay? So now I want to take a moment and do the melting point and show you how to prepare your sample.